Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn how to multiply and divide radical expressions. Now, I'm going to assume that you're familiar with some basics of simplifying radical expressions and that we need to know the following two properties. That is, it's called the multiplication property of roots. So if I have the nth root of a times the nth root of b, I can combine these to get the nth root of a times b. We've already used this in simplifying, but now we just want to use this when we're combining or multiplying radical expressions together. And similarly for division, if I have the nth root of a divided by the nth root of b, I could rewrite this as simply the nth root of the quotient a over b. Example 1. Let's go through this problem carefully to see the idea. So we're going to rearrange the factors here. I'm going to take the factors that are not under the root, 3 times 5, and then we're going to multiply together the factors that are the radical factors, so root 12 and root 6. So we get 15. And then we'll use that property of radicals we had before, which is that I can write this as the root of 12 times 6, which is 72. Now, if you want, you can simplify these radicals first. Sometimes it can be easier, rather than simplifying each one, might be easier to just multiply them out and then simplify at the end, which is what I'm doing here. So 72, you want to find the perfect square factors of 72. That would be 36 is the largest one. So we can write that as the square root of 36 times 2. So that will become 15 times the square root of 36, which is 6, times the square root of 2. And then we get 15 times 6 is 90 times the square root of 2. Example 2. Okay. We first notice we want to multiply out these two factors here. Now we notice though that we have conjugates here. So what I mean by that is we have 2 plus root 15, and over here we have 2 minus root 15. So the two numbers are the same, but the sign in between them is different. And so we notice if we know how to factor a difference of squares, if we have a squared minus b squared, that will factor into a product of conjugates, a plus b times a minus b. Now you can just multiply this all out using the distributive property, or we can just sort of work backwards from this. And so what we should get here is we should get 2 squared minus the square root of 15 squared, and that gives us 4 minus, if we square the square root of 15, that's 15. And so we get 4 minus 15, which is negative 11. Example 3. Okay, we can start by multiplying the factors that are not underneath the radical. So we have 2 times 3, right? We have 2 times 3 is 6. And then we're going to have the cube root of, we can multiply what we have inside. So 4 times 2 is 8. And then we have x to the 5th times x squared will give us x to the 7th. And so now it's multiplied out, but we have to simplify. So we can rewrite this as 6 times the cube root. So we want to factor everything or rewrite the interior factors there as perfect cubes. So we have 8 is actually 2 cubed. And then x to the 7th, I can write that as x to the 6th times x. X to the 6th is a perfect cube. It's x squared cubed. Finally, we finish simplifying. We'll have 6 times 2 is 12, right? We pull out that 2 cubed. It comes out as a cube, as a 2. And then we'll have x squared times the cube root of x. Final example. We start by using the division property of roots. So we can write this as the cube root of 81 a to the 7th b squared over 24 a squared b. Now, 81 and 24 have a common factor of 3. So if I cancel out the 3, I'll be left with 27 in the numerator and 8 in the denominator. So what I have here is I'll have the cube root of 27 over 8, and then a to the 7th divided by a squared will give me a to the 5th, and b squared over b will give me b. So what I'm left with here is the cube root of 27 a to the 5th over b. And so I can actually rewrite, so I want to pull out perfect cubes. So 27 over 8, I can actually write that as 3 over 2 cubed, because those are both perfect cubes, right? 27 is 3 cubed, 8 is 2 cubed. And then as far as a to the 5th goes, I can write a to the 5th as a cubed times a squared, because again, a cubed is a perfect cube. And then we have this leftover factor of b. Now we just simplify by pulling out the perfect cube. So I have 3 over 2 times a times the cube root of a squared b. And that's it. So these problems can be a little bit tough. My suggestion is just practice this a bunch until you have it down. All right, until next time, have fun.